The example I'm going to walk through now is a mechanism for the formation of an acyclic acetal. So in other words, we do not have a ring here in our acetal piece. It's actually going to be two acyclic pieces. Um, if you saw my video for the formation of the hemiacetal, you'll see that the first few steps are exactly the same, but then the reaction will proceed to move on to eventually get to the acetal itself. So as always, when we have acidic conditions, the first step is going to be protonating the carbonyl. And there's two ways this can be drawn. One is starting with the sulfuric acid. We can actually do the mechanism where the sulfuric acid protonates the carbonyl. Or the other acceptable route would be, because we have sulfuric acid present and an alcohol, the sulfuric acid might actually protonate the alcohol first, and your alcohol that's protonated could then be the proton source. But again, it just depends sometimes on the person grading, but I like to have sulfuric acid be the initial acid, and then uh, I don't use it really after that. So we protonate the carbonyl, we get the structure then shown, and at this stage, we do have that activated carbonyl, that more electrophilic carbonyl that's susceptible to nucleophilic attack. Now our alcohol will come in, and it will add to the carbonyl like so. So the first step was a proton transfer. The second step is our nucleophilic attack. And now we have our first alcohol that added. And what we're going to get next is our deprotonation step, our proton transfer. Another alcohol, again, is going to be present for that. And what you'll find with a lot of these, it's a lot of proton transfers. There's usually only one or two nucleophilic attacks and maybe one or two loss of leaving group sort of steps. Everything else is proton transfers to either neutralize your compound or intermediate, or to activate either an electrophile or a leaving group. So this proton transfer step is going to result in the formation of our hemiacetal. So at this stage, we're at the hemiacetal. The hemiacetals aren't particularly stable, and so they're going to usually keep going until we get to our acetal. So the next step of the mechanism is we've just recently protonated our alcohol. That's now going to be our acid to protonate our hemiacetal. But now we're going to protonate the OH section, not the OR section, because we need to make a good leaving group of that OH group. We need to make it water. It cannot leave as O minus because we are in acidic conditions. So what's going to happen is we get our water leaving group set up there. And in the next step, we're going to lose our leaving group. So the previous step was a proton transfer. Now we're going to have loss of a leaving group, in which we're going to reform our double bond, kicking out water. The reason why we're going to reform the double bond is because if we didn't, we would have a carbocation that doesn't have a complete octet. By reforming the double bond to this oxygen at the same time, forming that carbonyl-like structure, we just have the better resonance form, the one in which everything has an octet. So we reform our double bond or in the carbonyl, we kick out our water, and we're left with this intermediate. Now, again, it's like that initial step where we have that activated carbonyl. We have a more electrophilic carbonyl, which means we're going to accept a nucleophile, and it's going to be our alcohol. You can see now our alcohol is kind of doing multiple things. It is acting as a nucleophile to do the nucleophilic attacks, and it's also acting as a source for the proton transfers. So we're going to add our oxygen to the carbonyl. What's going to happen is we are going to get this almost complete acetal formation, but we still have it protonated, and the last step is going to be that proton transfer to get to the neutral species. And so I'm going to add the alcohol one last time to deprotonate, proton transfer, and we get our final product. So again, to form a acetal, you first do a proton transfer because you need to activate your carbonyl, make it more electrophilic. Then you're going to have your nucleophilic attack of the alcohol. Once you add that alcohol, you're going to have a protonated form that needs to be deprotonated through proton transfer. We then arrive at our hemiacetal. Once we get to the hemiacetal, we can further protonate to make a good leaving group. We lose our leaving group to get to the activated carbonyl species. Nucleophilic attack will then add our second alcohol, getting to our almost complete acetal structure. The only thing left to do is the final proton transfer to get rid of the charge and finish with a neutral species overall. The next video, I'm going to show something very similar, but instead of adding the alcohol multiple times, what we're going to do is have a diol that we start with, and we're going to actually get a cyclic acetal as the product instead of an acyclic variation here. It's the same mechanism you'll find. It's just that both of the alcohol pieces are on the same chain, and so it's going to be more of an intramolecular process from the hemiacetal to the acetal.